So section 3, we're going to look at the central limit theorem, which is actually one of the biggest and most fundamental theorems for statistics. And we're going to look at how it applies to sample proportions. So the central limit theorem tells us that if the sampling distribution is approximately normal with a mean equal to the population proportion and a standard deviation equal to the standard error, then the following three must be true. And so before I talk about the three conditions, I do want to mention that this is the notation for what this whole thing is basically saying. So it's saying that if the sampling distribution is approximately normal with a mean of p and standard deviation equal to this. Again, remember that if you don't know p, then you can estimate it using p hat, but that's only if p is unknown or not given. Okay, going back to the three conditions. So the CLT theorem, or the CLT, is true if 1. The sample is random and independent. So the nice thing about this is we're assuming that all of our samples are done with the simple random sampling, so our sample should be random and independent. The second assumption is that the sample must be large. And to check if the sample is large enough, we're going to be using these two criteria right here. So is n times p, or p hat, greater than 10? And is n times the quantity 1 minus p, or 1 minus p hat, greater than or equal to 10? So again, if p is provided, you use p. If p is not provided, then you estimate it using p hat. Finally, the third condition, or the third assumption, is that the population must be big. To check if the population is big enough, we're going to be using this. So capital N refers to the population size, little n refers to the sample size. So is the sample size at least 10 times smaller than the population size? Or in other words, is the population size at least 10 times bigger than the sample size? So we're going to go ahead and look at example 3. So the main thing about the central limit theorem is checking to make sure that these three conditions are true. This is so fundamental to statistics that I can guarantee you that it'll be on the exam. So please make sure that you know what the assumptions are and that you can check and make sure that the assumptions are met. Because without these assumptions, you cannot use the central limit theorem. So the example that we're going to be looking at, example 3, 200 randomly selected American drivers were asked if they text while driving. 152 admitted that they did. So what we want to know is, can we use the central limit theorem? And in order to know if we can use the central limit theorem, we have to check the three assumptions right here. So number 1, is it random and independent? Is the sample large enough? And is the population big enough? And so let's go over here. So the first requirement, let's call that assumption 1. Oops, you did not see that. So checking random and independent. So for this one right here, again, as I've mentioned a few times, we're assuming that the rest of our samples in this chapter are from a simple random sampling. So using a simple random sampling rules out or tells us that the samples are random, and if they're random, then they're going to be independent of each other. And so by simple random sampling, the samples are random and independent. And so in this manner, we can say that this is checked. So that's for assumption 1. So on your exam, when I ask you to check the central limit theorem requirements, this is what I'm looking for. So for assumption 1, can you explain that this random, or that the samples are random and independent because of the simple random sampling or the simple random samples that we're assuming. Now for assumption 2, what we want to check is to see if the sample is large enough. And to do that, again, we have to check this right here. So we have to check this side and the right side. So let's go ahead and do that. I'm going to go ahead and write that out. So what we need to check is, or before we even check it, let's determine if we're going to use P or P hat. So here we know that 200 randomly selected Americans were asked if they text while driving. 152 admitted that they did. And so in this case, do we know the population proportion of people who text while driving out of all Americans? No, we don't. But we can calculate the sample proportion. So out of these 200 randomly selected American drivers, 152 admitted that they did. Okay, so here, like I was saying right before this, 152 out of the 200 randomly selected Americans admitted that they text while driving. So our sample proportion P hat is going to be 0.76. In order to check the second requirement or assumption, we need to know n. Little n is our sample size, which is going to be 200 because 200 American drivers were randomly selected for this study. And so, again, for the second assumption right here, make sure you check both sides. So not just check one of this and ignore the other, but making sure you check both of them, because on the exam, the final exam, that will be one thing that I'm looking for, and if you don't have it, you will lose a point. And so I've already done that. So seeing on the left side right here, we see that 152 is greater than or equal to 10, so the left side is checked, the right side is also met, and so assumption 2 is met. Now the final assumption is that the population must be big. And so for that, we need to check to see if the population size is at least 10 times bigger than the sample size. We already know that the sample size consists of the 200 American drivers, so sample size is 200. Now, what would the population size be? So the sample size, or the sample, are those 200 randomly selected American drivers, which means that it means that they must have came from all American drivers. And so there's no exact way to calculate the total number of American drivers because that would be a lot. And so instead, as a quick way to check that, I'm just going to write all American drivers for my population size. And here we see that all American drivers is definitely more than 2,000. And so for this reason, the final assumption is also met. And so here, since all three assumptions are met, then we can make a conclusion. So first off, we can use the central limit theorem because the three assumptions are met. Now, what kind of conclusion can we make from this? So let's go ahead and look at the central limit theorem again. So the central limit theorem says that if these three assumptions are met, then the sampling distribution is approximately normal with a mean of P and a standard deviation of SE. So let's see what that would mean for this example. So as I have mentioned, the central limit theorem tells us that if these three requirements are met, then the sampling distribution is approximately normal with mean P and standard deviation SE. But the thing is, we were not given P, and we had to calculate P hat instead. And so our conclusion would depend on P hat and the standard error estimated instead of P and SE. So here we know that P hat is 0.76. Let's look at what else we know. So we also know that with P hat, and since we know n already, we can calculate the standard error estimated. So we're going to go ahead and just do that. So while I'm fixing this, go ahead and take a look at what I did to calculate my standard error. Okay, so here standard error estimated is p hat times 1 minus p hat all over n. Take the square root of that. We get a standard error of 0.0302. And so since we know p hat, and since we calculated the standard error estimated, our conclusion is that the sampling distribution is approximately normal with a mean of 0.76 and a standard deviation of 0.0302. This is going to be very, very useful in the future or in the near future when we start calculating probabilities using this kind of conclusion. In this fourth example right here, we're going to try to find probabilities with the central limit theorem. And so what I have done right here in example 3 is only the first 2 steps of finding probabilities with the central limit theorem. We're still going to include a third step in here, which is going to consist of what we learned in chapter 6. But I'm going to do that in another video since this one's going to cut off in 4 minutes, and that's not going to be enough for me to go over it. And so in the next example, I'll talk about finding probabilities with the central limit theorem.